Hey kiddos, today we're going to be talking about transformations, and the first transformation that we're going to deal with is translation. So, few vocabulary things. A vector is a quantity that has both direction and magnitude. Those of you who are Despicable Me fans may remember this. Or size, and is represented in the coordinate plane by an arrow drawn from one point to another. So, in this example, a vector is drawn. The initial point or the starting point of the vector is P. The terminal point or the ending point is here where it's Q. The vector is named ray PQ or vector PQ. The horizontal component of PQ, meaning horizontally left or right, how we move, is 5. The vertical component, how we move from down to up, is 3. The component form of a vector combines the horizontal and vertical components, so you would see it as such, where it is 5, 3. Sometimes we would also write it as such x, since we would write 5 plus 5, and y, since we went up 3 plus 3, is another way to also term that. A transformation is what this whole unit's on, and it's a function that moves or changes a figure in some type of way. So the new figure is called the image. The original one is called a pre-image. Okay, the points on the pre-image are the inputs for the transformation. The points on the image are the outputs. So congruence transformation is when the new image is congruent to your pre-image. All right, now we are looking at translation, okay, which is what we're going to focus on today. A translation moves every point of a figure the same distance in the same direction. You can use prime notation to name an image. If the pre-image is point P, then its image is point P prime, which is what this denotes, okay? That's how you'd read it. A translation maps or moves the point P and Q of a plane figure along a vector. So essentially, kind of what I was showing you earlier in that previous example. These are basically the directions of how the move is happening. So the transformation would be written then in this form, where A is the distance moved horizontally and B is the distance we move vertically. So let's look at our first example. All right, so we have a triangle QRS, which has these 3 vertices, which you can see I've already plotted, so make sure you do that. And we're going to graph a new triangle QRS with this translation of x plus 4, y minus 5. So remember here, x is going to be moving horizontally, so right or left. So if it's positive right, negative left. And your y value moves vertically, which is positive is up, negative is down. So based on here, we're going to be going right 4 units and then down 5 units. And we're going to do that to each and every one of those points. So we're going to move it to the right, 1, 2, 3, 4, and then down 1, 2, 3, 4, 5. So that's where my new value of Q would be, or I should say point Q prime or Q prime. So S, right 1, 2, 3, 4, and then down 1, 2, 3, 4, 5 puts S prime there. And then finally R, right 1, 2, 3, 4, and then down 1, 2, 3, 4. Put R prime there, and then I can connect the dots, and that would be the new triangle. Composition of transformations is when two or more transformations are combined to form a single transformation. The lengths and angle measures will be preserved in the final image. So in this example, the composition of 2 or more translations is a translation. So for example, this point originally this segment is originally here. And then notice it is moved here. That's the first translation. And then the second translation creates it here, which this is then identified as a composition. All right, so next example, identifying a vector component. So we're going to name the vector and then write its component form. So the starting point is J, the ending point is K. So the name of my vector is going to be vector JK, and I'm very serious. Ha ha ha. And then the component form, notice here it goes over 1, 2, 3. And then from this point here to there, it is 1, 2, 3, 4. So the component form is 3, 4. All right, so for the next one, we're translating a figure using a vector. So we have a triangle here, ABC, with vertices of A being at 0, 3, B being at 2, 4, and C being at 1, 0. We're going to translate this triangle using the vector of 5, negative 1, and find the coordinates of the new image. Okay, so based on the pre-image, we're going to discover a new image, and the vector form is 5, or component form is 5, negative 1, which basically means we have x plus 5, y minus 1. So remember, x goes left, right, so we've been moving to the right 5. Y moves up, down, which means we're moving down 1. So we have to move every single point just like that. So we're going right, 1, 2, 3, 4, 5, and then down 1. So that's my new A prime. B over to the right 5. 1, 2, 3, 4, 5, and down 1. There's B prime. And C, same thing. 1, 2, 3, 4, 5 to the right, and down 1. C prime. That would be our image. So those coordinates are 5, 2 for A prime, B prime is 7, 3, and C prime is 6, negative 1. All right, so this example, we're writing a rule now for the translation. So we're going from the blue, which is the original or pre-image, to the image, which is in red. So the question is, how did these points move, essentially is what we're looking for. So first let's look at our x value. How did the x value move? So pick a point and work with one point, okay? So let's say I'm looking at point C. I can clearly see that it moves to the left 1, 2, 3, 4 units. And then I can see that the y value moves up 1 unit. So based on that, x goes left 4, which is a minus 4, and y goes up 1, which is a plus 1. So if I were to write that in my vector form, it would be negative 4, 1. All right, so this next example, I actually want you guys to do on your own. Oh, yo. And it is a quadrilateral, so hence why there are 4 points. So you're going to graph the pre-image first, and then you're going to follow your translation rules here to draw the new image. Then you're going to write what this is in vector form, and then what are the 4 new points. So now let's do a composition. So basically that means that there's more than one move happening here, okay? So for the first problem, we're beginning with RS, as you can see. So this is our pre-image, and we're going to make this first move, which is right here, which tells me to go right 5 and then down 2. So I'm going to do that first. So this is where my new R prime and S prime is. And notice that's not it. I have a second translation. So now I'm translating it again, this time to the left 4 and then down 2. So we get, all right, and this is where we would end up with our final move. So the vector is basically instead of me having to go through all of that work, the vector that we're going to write is what is the quickest directions that you could give me to go from the pre-image to the double prime, essentially. Okay, so that would mean that I would go right 1, and then we would go down 1, 2, 3, 4. That'd be the quickest way to get me from the pre-image to the double prime location. So in this space here, we can fill in the coordinates, which were negative 3, 3 for r prime. S prime was negative 1, 6. R double prime, which was the final location, was negative 7, 1. And S double prime, negative 5, 4. Awesome sauce. Hope this was pretty simple. See you soon.